In this video clip, I'm going to take a look at the adaptive mesh model that was proposed by Figulewski and Gao. So that's quite an interesting paper, and they come up with a mechanism for accelerating the trinomial model and addressing issues relating to nonlinearity error that arises in latest techniques. By using a finer mesh. So from the penultimate to the final set of nodes in a trinomial tree, we looked at trinomial tree proposed by Phelan Boyle in that previous page here. Between the penultimate and the final set of nodes in a trinomial tree, Figulewski and Gao propose inputting in a finer mesh, and that tends to reduce error. Now, I have two snippets of code here. The first is proposed by Fabrice Roua, but you need to set up boost libraries in order for this code to execute. So that's a little bit more technical, but I'm going to leave that snippet of code there because the second snippet of code that I have piggybacks off this, and I just make some adjustments so that, first of all, we have a dividend included. I've taken out turbo libraries, and I've included in vectors, which is probably slower, but still we're going to make use of this. So let's just copy this snippet of code for a moment. And what we'll do is we're going to estimate the value of a numerical call option, and the parameter inputs for the stock and the strike and the time period, the risk-free rate, the dividend, the volatility, so on. They're consistent with Table 2 from Brody and Temple 1996, and you'll find that in this link here. And we have the true value with a 15,000 step binomial model. Okay, so let's go into online GBD. Okay, so we'll go into online GBD, which is an online C++ compiler. We'll remove whatever fragment of code is there. We'll designate it C++. We'll paste in the snippet adjusted to remove turbo libraries, and we'll execute. Now it's running at 5,000 steps, so perhaps I should pause. And we have some output here of the AMM price is 9.0656, so 9.066. If we go back into Vinegar Hill portal, we can see that we get a similar result. We could try 120 here just to see do we get a value. So let's just do one more check here, and we'll change the spot price to 120. Maybe I'll reduce this to 2,000. Maybe I'll leave it at 5,000. Let's run and see what output do we get. And I'll pause the screen because this will take a minute or so. And you can see here for the American call option with a spot price of 120, we get an AMM price, adaptive mesh model of price of 2141. And we go back into our Vinegar Hill portal and we get 2141 as well. So these results are relatively good. And this is an implementation, could be quite useful for the adaptive mesh model.